not approaching infinity the other day. We were approaching asymptotes, right? And when we approached asymptotes, our answers were infinity. Now when we approach infinity, we're talking end behavior, right? What we're talking about is potentially horizontal asymptotes, because that's what happens when you go out towards the infinities, is that your graph typically approaches horizontal asymptotes if there are any. And if there aren't any, then we just have to think about end behavior, like positive degree polynomial, positive even degree polynomials, odd degree negative polynomials, stuff like that, where we would talk about end behavior. So as this function approaches positive infinity, what's its limit? Where is it going? Negative infinity. As this function approaches negative infinity, where is it going? Positive infinity. So if there's no horizontal asymptote, it's probably just shooting off towards one of the infinities also. But when you approach infinity, your answer definitely can be numerical. If you have a horizontal asymptote at y equals 5, then as you approach one of the infinities, it's probably approaching 5. So a little bit different than, a lot different, although the wording sounds very similar to what we did on the Friday before break. So I reminded you at the top how we come up with the horizontal asymptote, so the degree rules. So small over big means y equals 0 is your asymptote. Same over same means y equals the ratio of the leading coefficients. And big over small means there is no horizontal asymptote, which means these answers are probably going to be infinity or negative infinity. Whereas these answers will probably be numerical. So, first function here, if you think about your degree rule, it's a small over big. Yes? So, y equals 0 is definitely a horizontal asymptote. Just for the sake of simplifying it, because we should always do this with rational functions, we should factor. And cancel and see if we can simplify this and have a simpler visual of what's going to happen here, which pretty straightforward. This is going to look like the graph of 1 over x plus 4, with the exception of it will have a hole at 2, 1/6 to be exact. So both end behaviors, if you think about this, and again, sketching the graph of this is not going to be the most efficient, but just to fully understand what is happening here, this is just a rational function that got shifted left 4 units. 1 over x is the parent graph. This is 1 over x plus 4. So it got shifted left 4 units, which moved the vertical asymptote. The horizontal asymptote being shifted left 4 units didn't really change anything. And then there was no reflection or anything, so our graph is still just nestled in those first and third-ish quadrants. I'm talking the new quadrants based on our new asymptotes. And so as we approach infinity, see, we're not approaching the vertical asymptote anymore. We're approaching infinity. So as I trace along this graph going towards infinity, this value is getting closer and closer to that horizontal asymptote of 0. So that limit is 0. And the same is true as I approach negative infinity. If you follow that graph going further and further to the left, it's squeezing up and up and up and up towards the x-axis, which is a y value of 0. So as my graph is approaching negative infinity, my y value is getting closer and closer to 0. This one is getting closer and closer to 0 coming from the positives. This one's getting closer and closer coming to 0 from the negatives, but that's not important for our answer. It's 0 either way you look at it. Okie doke? Any questions on that? Okay. This particular function is let me tell you what happened when my power went out the other night. My child was going to be freezing cold, we decided, so he was going to sleep in bed, which he did, and then he proceeded to get the 24-hour bug in bed, which was great. So I'm just on call in case it's not really gone, but I think it is. I think he's there. All right. Another rational function, degree rule, same over same. So the horizontal asymptote is where, John? How'd you get 8? Look back up at the top of your paper. What's the same over same rule? Three. Yep. The leading coefficient of the top is 3. Leading coefficient of the bottom is technically a 1. 3 over 1 is 3. So, unless this is like a funky thing, which it's a typical rational graph, it's going to be approaching that horizontal asymptote on both ends. So as we approach positive infinity, it's approaching 3. As we approach negative infinity, it's also approaching 3. The only time those might be different is if we have a case of 2 horizontal asymptotes, which we will have. You've never seen a function like that yet, but we will, and we'll cross that bridge when we get there. But when it's a typical rational function, you'll know it when it's a weirder version of a rational function. And I'll just show you this. 3x minus 8, minus 2. Over x minus 8. Here it is. Oh boy, what is that? Hold on, I don't like that background. Did I lie to you? 3x minus 2. We should graph this by hand. Divided by x minus 8. I think I lied to you. No, I didn't. So when I graph it, this is what I see, right? And it looks like I lied to you. Why does it look like I lied to you? Who can explain away the fact that I haven't really lied to you? Because if you were looking at this, you would say the limit as x approaches infinity is what? You would probably say negative infinity if someone showed you this picture, right? And that's not what I've told you. I've told you as it approaches infinity, the answer is 3. Why would that be? Why is this picture really lying to me? Aiden? Right, we're only seeing a part of it. The vertical asymptote is where, Aiden? 8. So on one side of 8, we're approaching negative infinity. On the other side of 8, what you don't see is we're approaching positive infinity. So if I open this up from like negative 20 to 20, you might believe me more. Yes? That it's going to approach 3 whether you're going towards negative infinity or positive infinity. The table will really shed light on that. If I go towards negative infinity, it's just going to get closer and closer to 3. It won't ever pass 3. And if I go towards positive infinity, so we have to wait a second here. These numbers are also going to get closer and closer to 3. But coming from above 3, they're shrinking towards 3. Can we all see that progression happening? You know, some weird stuff happens in the middle, certainly, while you're approaching this. You know, if you're going this direction, all of a sudden the numbers get really huge. I don't know if you guys saw the error come up when x equals 8. That makes sense. And then on the other side of it, they're really high numbers, but then they were slowly coming down closer and closer to 3. Okie doke? Any questions? All right. Another typical rational function, again, since we're looking, and you can just look at what you're finding the limits surrounding, you're looking for the limit as something goes towards infinity and negative infinity. So you are definitely talking about end behavior here. Okay? You don't really need to factor and cancel or worry too much about that when you're approaching the infinities. Because where the vertical asymptotes are, that's not really of interest to us. If we were approaching a number, x approaches 8, you would want to be concerned with, is that an asymptote or not? Can I directly evaluate, but not so much with the infinity end behavior. So big over small means there's no horizontal asymptote. Yes. There's a slant asymptote. Do you guys remember how we find the slant asymptote? It's not going to be a horizontal line that we approach when we go for our end behavior. It's going to be some other type of function, whether it's a diagonal line. It's still an asymptote, it's just not horizontal. Anybody remember how we do that? How about for 2 bonus points? You don't even have a guess. Trista, you look like you want to guess. Are you asking me or are you telling me? You got 5 seconds to decide if you're telling me as a bonus guess, or are you asking me as just a fun question? You're telling me? Correct. So I'll give you your 2 points. You do long division, okay? If I do long division, let's just think loosely about this before I specifically do it. A cubic function divided by a linear function is going to give you what kind of function? A cubic function divided by a linear. A quadratic. X to the third divided by an x is going to give me some sort of quadratic asymptote. Okay? It's not horizontal, so that's why it's the horizontal part does not exist. But that doesn't mean there's no end behavior asymptote. We still have one. Now, I'm doing this only for the sake of reviewing and, again, to build the concept. You are not going to have to do that. Loosely speaking, when you do that division and it's a quadratic, is it a positive quadratic or a negative quadratic, 3 divided by 1? Positive. So your quadratic is going to look something like this. But that's going to be the asymptote. So whatever this crazy function does, as you go towards positive infinity to the right, it's going to get closer and closer to the quadratic asymptote that's opening upwards, which means it is going to go towards infinity. As you trace along your function, however it might be like bouncing back and forth, towards the negative infinity, it's going to get closer and closer to the line of your quadratic asymptote, which is also going towards positive infinity. So this will be positive infinity either way you look at it. Okay? Now, that thought process will be enough to get your answer, but in order for that thought process to really make sense, we're going to do this whole thing out. So we are going to do the long division. There's 0x squareds, by the way. And you know what I just realized? This is a prime candidate for synthetic because that's a linear factor. So I'm just going to do synthetic with 3x cubed, 0x squareds, 5x's, and 2. Bring down my 3. 8 times 3 is 24. Oh boy. 8 times 24 is 1. Did I do something wrong? Oh, you're the best. 192. That'll give me 197. 197 times 8, 1576. Add those up, you get 1578. The remainder means nothing, okay? The quadratic asymptote that we will follow is 3x squared plus 24x plus 197. I think I'm going to have to mess around with the window quite a bit for you guys to see this. But I'm going to graph that function, and I'm going to graph that asymptote to show you exactly how this whole thing transpires. So, y equals, oh boy, 3x to the third plus 5x plus 2 divided by x minus 8. So there's my original function. And then after that will come my asymptote. So zoom 6, like the standard negative 10 to 10 viewing window, I don't think is going to be very telling. Oh, not bad. So that's my function, although I have a feeling I'm missing quite a bit of it over here, mainly because I was pretty confident that as this is approaching infinity, my function will also approach infinity, right? So I think this will probably turn around. I'm not seeing any of this quadratic, probably because it got shifted up 197 units, right? So I'm going to go negative 20 to 20, and then I'm going to go negative 200 to 200. So here's my first graph, which still has not turned around, and there is my asymptote. Window. Negative 100 to 100. Uh-oh. It's going to make a liar out of me. It's not turning back around. Brainstorm with me. Why is this happening? There's bonus points on the line. Why is it not turning around? So this one is wrong. Does everybody see that? Why did that happen? It should be a squared. All right, round 2. So I can think my way through this. Let's plug in something huge, okay? And see why this would be happening. Oh, it's so hard to plug in something huge, though. Let's say I plug in 10. We're worried about this one because that one worked out fine. But as you approach infinity, if I plugged in 10, p of 10, which is nowhere near infinity, but I'll come back, I'm going to get 3 times 1,000, right? 3 times 10 cubed plus 5 times 10 plus 2 over 2, really. Yes? Which is a really big number divided by 2, so probably still a pretty big number. When I plug in 100, the numerator is getting a lot bigger. Agreed? And 100 minus 8, but I'm also now dividing it into parts. Like more parts. Does that make sense? So this is a tough case where plugging in is not very telling, because you'd almost have to be comparing the degree at which the numerator is increasing versus the degree at which the denominator is increasing, and thinking about how that division works with each other. That's like already making my mind boggled, so I would steer clear of that. I don't think it's an easy thing to wrap your head around without the calculator. But what I'm getting, and did I type something in wrong? Is that when I plug in bigger and bigger numbers, this is still being positive, isn't it? So why was my graph going to the negatives? as x goes towards infinity, why is my blue graph negative? Table. Maybe the table can help us. It's not. It's getting humongous. Does anybody know what's going on here? What am I going? 0 to negative 100 to 100. So, hear me out here. When I go from 0 to 100, am I correct in that those are showing me negative values? But these are showing me positive values? Is it because it's so far off the graph? $2,000. Is it because the numbers are just so big? Oh, yeah. The good news is, I think we're right. And the better news is, you don't have a calculator to confuse yourself when this happens, and this is why having a calculator in your hand can be like mind-boggling, because you really got to like think through and figure out what window would be appropriate. So as you, the asymptote is at 8. So as we get closer to the asymptote, it is shooting off towards negative infinity. The problem is when we pick up on the other side of 8, it is so much higher than this is showing. I only went to 200, and my values are in the thousands. And not only that, they're growing, right? They're 2,000, they shrink a little bit to the 1,000s, but then they start going back up again. So I don't think I'm going to see much of anything. I'm going to go back to the negative 2020. I don't think I'm going to see much of anything until, as far as the other end behavior, until I go from like negative 2,000 to 2,000. So there is my blue function, and here comes my asymptote. You follow? Okay, so I was going to say my algebra was making a liar out of me, but it's not. We are correct, and here I've gotten to the bottom of why our graph wasn't showing it, because our window wasn't accurate. But now that you see it, there's the blue original graph jumping on either side of the asymptote at 8, and then the red is our asymptote that we're getting closer and closer to as we approach negative infinity, and we're getting closer and closer to as we approach positive infinity. They're both positive infinities. Does that make sense? Okay? All right. So, again, you won't have the complication of the calculator, and now you'll thank me for not letting you use the calculator, because it does nothing but make you think harder. Oh boy. Oh boy, kids. Let's think about homework here. I might have to switch this up. How about on your homework worksheet, just do the first 4 on the front, so this 1 through 4. And on the back, I'm going to have you just do 5 through 8. So we'll stop there. So everything on the front, so 8 problems is all. And I cut it up and made them all rational, so it's what we did. The back side of our note we'll continue on tomorrow, and it'll get into like non-rational stuff. Good? Don't go try and do the whole worksheet.